Okay, in this model, what we see is this is very similar to the model we worked with the other day, except this time we have a convergent boundary of oceanic crust. You can see in the cross section down below with a continental piece of continental crust here. So this is the thick continent here with some oceanic crust coming off to the side. So, and then over here, we've got the oceanic crust subducting or going underneath, being pushed underneath because it's more dense. Um, and this is, and up here you can see this is the aerial view at the top. And this is trying to represent the idea of this is South America. This is the coast of the west coast of South America. If you were to look down here, this is the Pacific Ocean on this side, right? This is the Pacific Ocean. This is the Pacific Ocean. And over here, we've got the Atlantic Ocean over here, Atlantic Ocean over here. And then we've got the continent. So what we're going to do is we're going to run this simulation, and we're going to see that the South American plate is going to move to the right, to the left, sorry, or to the west, whereas the Pacific plate or the Nazca plate actually is going to be moving to the right or the east. And then this is scheduled to run over a number of millions of years because remember, this process is very slow. And we're going to see, as we expect, we're going to expect to see earthquakes along the plate boundary here as these two plates are rubbing up against each other. We're going to get lots of earthquakes down near this trench. You'll see them up here, but they're happening down in this area of the cross section. Under deep underground, and then also you're going to see earthquakes. You're going to see volcanoes, and those volcanoes are going to show up sort of along this in a line along this coast, not directly at the coast, like right not on the beach or anything, but like a little ways inland. You'll see those volcanoes. Now, one thing I don't love about this model is that you don't see the melting of the crust down here, and you don't see the magma rising up to form the volcano at the bottom, which is unfortunate, but it is a limitation of this model. So we're going to run this model, and we're going to see what this looks like over a course of millions of years. You can see the plates moving, right? The plates are moving, and we're seeing those earthquakes, the black dots forming right along the coast, right along that boundary, and we're seeing volcanoes forming a little bit inland in a row, nice line across the middle of that, the edge of that continent there as it moves. And again, down here you're seeing the continent push over the top of this oceanic crust, which is pushing down below. And that was about 200 million years. So we had a bunch of motion across as this continent is being pushed by the convection currents underneath, and this one's being pushed together by the convection currents under here. That's sort of pushing them towards each other, right? They're heading in this direction. And then also, one thing you can think about is a connection to what we talked about in previous lessons, but out here somewhere, there's got to be another boundary. There's got to be a divergent boundary, which is growing new rock that you're seeing over here. As the plates separate somewhere off the screen. That would be the mid-Atlantic ridge if this was South America here. So again, here this mountain range of volcanoes here represents the Andes Mountains or something similar to that. And then the black dots that you were seeing pop up periodically were earthquakes as these continents came together.